Welcome to our lecture on the SQLite databases and Android programming. I've fallen a bit behind on updating the Scrum board, so I'm going to go ahead and move a few things over. We officially have switched from our first sprint to our second sprint because we've completed the stories required for our first sprint. Traditionally, what we do at this time is have a review of the sprint and a retrospective, where we decide, what kind of things worked well, what didn't work well, what can we do to make things a little bit better. That's typically what happens at this point. Then we have a sprint planning meeting where we decide what stories we are going to accomplish in the next sprint. So at this point, I'll start moving over what we've already done. Research location service is done. Wow, okay. It's kind of hard to fit it on this small resolution. Create a location listener implementation. We did that as well. Move that to complete. Enable the GPS. We've done that. Okay. Create the plant service interface. Yeah, we did that. Create online plant lookup. We did that. Remember, let's see. I hope I'm putting these in the right place because it's kind of hard to see on this little resolution. The online plant lookup, remember that we have the plant search that will go out to the internet, search for the plant, and we then take a string and chop it up based on its delimiter character. So we did that. Create plant service stub. Yeah, we did that. Create a plant service, a plant search screen. Did that. Create a results screen. We did that. So, wow, we look really good. So, all of our objectives from the first sprint have been met, and actually we met them a couple of weeks ago, so I guess really we've been in the second sprint for about a week now. What we need to do now is think of the stories for our second sprint. So, we have allow user to take a picture, click on the picture, and see plants with the selected color. We can at least get into the taking a picture part of that. I do, in real life, I do have the real one working where you can touch the picture and see what color results and all that. I don't know if we'll have time to, this quarter to get to that, but we could start to put some stories under there. First, though, I want to say create offline plant service, which uses SQL. Let's say SQL, or let's just say persistence on the Android device. Okay, and we choose OK. Okay, now we'll add a few stories here, we'll add a few of our tasks here. One is to create the class. Yeah, okay. Let me be more specific. Create the offline plant DAO class. We're going to give that's going to be fairly straightforward. We'll give that a Fibonacci number of 2, and of course we'll assign it to me. Okay, we probably need to do a research task, research SQLite. If there's something where we don't know enough information about it to effectively do it, we'll typically make a research task out of it. So research SQLite, we'll make that a 2. Brandon. Okay, then let's say create initial database. Okay, schema. Okay, we'll give that a 2. I keep giving these 2s. Assign that to me. Okay, so these are all the things we're going to do today. Create our queries. Again, I'm going to say 2 on that. Okay, and we also need to create a specimen DAO. We have a plant DAO. We don't yet, I didn't assign that to me. We don't yet have a specimen DAO. So I'll assign that to me. Sorry, DTO. We'll reuse the plant DAO. That'll be pretty simple. We'll make that a 1. Okay. For take a picture, let's put some tasks under here. These 2 stories are going to wrap us up for the quarter. As you can tell, they're 2 of the more complicated stories that we have. So those should wrap us up for the quarter. Okay, so take a picture, research camera, okay, 1, Brandon, okay, let's see, create supporting UI classes. which includes a layout to show the image from the camera. We'll give that a difficulty of about 3 actually. Assign that to me. Okay. Investigate threading. Okay. 2. Or let's just say implement. Implement threading. Assign that to me. Okay. Let's see, what else do we need to do? Save raw bytes to the file system. Okay. 3. And me. And that should be enough to get us started. Those tasks should wrap us up for the quarter, I think. I won't worry about the touch interface. That does make things a little bit tricky. If we have extra time, maybe we'll look at it, but if not, no big deal. So let's start with our offline plant service. We want to create offline plant DAO class. I'm going to move that into in progress and create a specimen DAO. Those are the 2 things that I'm going to work on right now. First of all, if we take a look at our existing plant DAO, we're missing one piece of information that we get back from our online plant service. Remember, our online plant service, one of the things that it gets is the ID of the plant, the unique identifier. And we want to, in my case, I'm going to keep the unique identifier synchronized with the online plantplaces.com. Unfortunately, when I put this together, I didn't have an ID defined in my plant DAO. So I'm going to go into my plant DAO and just say int ID. Okay. And then I'll put a note here, the primary key from plantplaces.com. Okay. And right click, refactor, and encapsulate field. Okay, and okay. Okay, save, and go to my online plant DAO, and then we'll populate this. This plant.set ID, whoops, plant data 0. Okay, there we go. Just a little bit of unfinished business. Now don't get mad at me. What's wrong? Oh, I need to convert to an int. That's what's wrong. Integer.parseInt. The reason I'm doing this now is we're going to need this plant ID as we save. Come on, what's wrong? Oh, did I not? That's weird. Did I give it the wrong? Okay. I didn't give it the proper data access. There we go. Okay, and everything works well now. So the reason I'm going to get this is because I'm going to want to associate this with the specimen that I'm saving. Okay, so well on the news, on that note of our plant DTO, let's also think about what we're going to need to save for the specimen. For the specimen, we have latitude, longitude, and description. And remember, a plant is something you would look at in a textbook. It's something like an Acer rubrum, a red maple, and it has some characteristics in general that we can describe about all Acer rubrums. But then a specimen, on the other hand, is a specific plant that you could go out and touch. Okay, so if you have an Acer rubrum in your front yard, that is a specimen of Acer rubrum. So what we want to store here is latitude, longitude, description. And also we'll want to associate it via a foreign key with the plant itself. So we'll want like a plant ID field as well. Those are the things we're going to want in our specimen. So I go to my DTO. Okay, move this guy back out. I go to my DTO package. Okay, one moment. Occasionally Screencast-O-Matic disappears and I don't know what's recording, so I have to do that and put it back to where it was, and we're good. Okay, so I go over to my DTO package, right click, say new, class, and we'll say specimen. Okay, and finish. That'll work great. Okay, specimen, I'll say, let's see, we'll just make our attributes now and then we'll encapsulate them. So we'll say int ID, we'll say for that primary key of the specimen. Okay, int plant underscore, no, plant ID like that. Okay, foreign key back to the plant. Okay. String description. Okay, and we'll say description of the specimen. This next one I kind of struggle with, which is latitude and longitude. And again, in the real life plant places, I originally saved those as doubles and later regretted it. Because with doubles, we have floating point arithmetic, which is where 1 divided by 3 is 0.333 continuous, but a double has a limited area where it can store data. So those inaccuracies sometimes will go from being just rounding errors to actually being errors. And anyway, with GPS locations, we're usually storing a number of significant digits after the decimal. So on the other hand, it's very likely we would want to use math on our latitude and longitude coordinates, so they should be stored as numbers. So you could make a good argument that latitude and longitude should be strings or should be doubles. You can make a good argument either way. As a matter of fact, what I will do is just see how did we store those on the location finder? Probably as doubles. We did. I'm thinking about just making them strings. Let's see, latitude. Well, now how do we get them? That's a good point now. See, okay. So we do get them as doubles back from Android. Okay, well, all right, there we go. We'll make them doubles. Okay. So double, latitude, double, longitude. I won't put a comment there because it's obvious what they are. I'll save. What I will do, though, is put a copyright at the top. And then java.class description here that says a specimen is a plant at a location with unique values of its attributes. Okay, this will cover us for now. And in the real life plant places, there's actually a lot more in specimen, but this will work for our needs. So I'm going to save, and I'm going to right click, do the old refactor. Okay, and encapsulate fields. Sorry, I had a NetBeans moment there. That's what it is in NetBeans, and I got lost because I couldn't find it. Right-click source, generate getters and setters. I am recording this class and my other class, which is Computer Programming 2, which does use NetBeans. I typically record lectures for both in the same day, usually one right after each other. So I have to switch from Eclipse to NetBeans and occasionally have a brain cramp like that. So select all, and let's make access modifier public. That's good. And OK. And we probably should make all of our attributes private. There we go. Okay, there we go. And we look good. Okay, so create specimen DTO. We'll move that to complete. Okay, next in progress is create the offline plant DAO class. So what do I mean by offline plant DAO? Well, keep in mind that we want to be able to leverage the network when we can, but especially with the cell phone, we have to be very aware that it will typically toggle online and offline as it has network coverage, and we don't want to interrupt service to the user. So online, if we were online 100% of the time, it'd be great. We could just use the resources over the web to save our specimens. But we can't assume that. We can't assume we're going to be online all the time. So we make an offline plant DAO where we will store data locally on the phone and then synchronize it later. Or we can pull down data from the liveplantplaces.com, and then we can have that data available for our use while we go into an offline mode. And again, this happens more frequently than you might even imagine. When I was in England getting plant locations, I didn't have network coverage because my phone doesn't work in England, but I still wanted to be able to use plant places, and I still could get GPS because you can get GPS satellites worldwide. So I made a lot of use of offline online mode. I was offline the entire time in England. I was there for a month in January, and then I came home and synchronized back online as soon as I came home. So offline means let's assume we don't have network coverage. Instead, let's use persistence mechanisms that are local on our phone. Okay, and it's funny, I can tell you there's a very similar analogy with this in real life because these are the kind of things we work with in point of sale as well. When what happens when the network goes offline? How do we continue to sell items and store transactions? And then what happens when it comes back online? How can we do it in a seamless manner that the cashier or the operator won't notice? Okay, so I'm going to go to my plant DAO, and remember we have the online plant DAO, okay, which implements iPlant DAO. Luckily, since we've created this DAO interface, we can continue to work in that manner. I can right-click, choose New Class, and I'll say Offline Plant DAO. That superclass is fine for the moment, but not really. We're going to look at that in just a second. Let's go ahead and choose iPlant DAO. Yeah, this will work for us. This will work. Okay, so we're going to implement the same interface as our offline plant DAO does, but the superclass is a little bit tricky, and I'm not really keen on how this works, but it's the way it works, so we'll roll ahead with it. I'm going now to our presentation on SQLite. Okay, and the reason why I'm jumping here after starting that class is we actually need to extend a specific class. Okay, we need to extend a specific class. We can't just extend object. But to know what that class is, we have to come over here and take a look at our presentation. So SQLite is the database that we will use on our Android device. What is SQLite? We keep in mind that we're running on a very resource limited device. While we get used to all the fancy stuff on our phone, it's nowhere near the amount of computing capacity we'd find on something that has the advantage of being plugged in all the time. So we don't really want to store gigabytes of data on our phone. We just want a convenient way to store data and to select data. So it's a subset of SQL 92, but not fully compliant, just enough to be usable on a mobile phone. Basically, something between a flat file and a true fully compliant SQL database. There are no data types in SQLite. Instead, it's self-typing. It's kind of like variables that don't have type, like you'll see in JavaScript or Visual Basic. The data type is inherent in the data itself. What we'll do when we create a SQLite class is we will define our create statements, our schema, in other words. And we can define a primary key. Might be a good idea to not only use this primary key indication, but also auto increment to say, okay, each time we add a new row, automatically increment it. Now, this is the slide I wanted to get to because this is the class that we must, or that we should extend. It's a little bit quirky, but it will work for us. First of all, we need a constructor. But what's weird is think about superclass and subclass. Remember that a subclass can override methods from the superclass. And also remember the rules about constructors, and this is very important. A default constructor will be provided to a class if you don't specify a constructor. Okay, you'll get a default constructor, and that is a constructor without arguments. However, the minute you do provide a constructor in a class, you no longer get the default constructor unless you specifically place the default constructor in there. If you extend a class, you have to make sure that your subclass has a way of calling a constructor from the superclass. So this is a bit goofy because the only constructor for SQLite Open Helper actually takes 4 different parameters. So when we extend this in our DAO, we're going to have to figure a way to call that superclass constructor with 4 parameters. Next, we have a couple of abstract methods that we have to implement in our subclass. One is onCreate, and this is the statement that will be invoked the first time our SQLite database is accessed. This will contain the create statements for our entire database schema. Now, one warning, and this is something I found out by experience, and this is a major warning. OnCreate is only called the very first time the SQLite database is accessed, period, no matter where it's called from. In other words, right now we're making a plant and specimen DAO, okay? If later on we add, say, a site DAO or some other kind of DAO and we want to add another table, onCreate won't get invoked. It only gets invoked literally the very first time you try to access the database. In other words, you have to really think of all the database schema you're going to want the very first time you create this onCreate statement. They should all be in there, all your schema information. If not, then you have to upgrade, and that gets a little bit tricky. OnUpgrade is the other method, and this method gets called when you upgrade the database schema. When I originally made these slides, I got it from the Apress book, or I was basing these off of the Apress book, which I probably will never buy another Apress book again. I was very unimpressed with what they had in Android and BlackBerry. On the OnUpgrade, they said, oh, just ignore this. You don't need to do anything with it, which really wasn't a good idea. OnUpgrade says, okay, if the database gets upgraded, it's going to blow away all the data that's already there. So OnUpgrade will get called first and will allow you to do something like back up the data before the new schema is in place. What you might want to do here is create new, just temporary backup tables, put the data in there. Then when the new data schema comes down and it deletes the old schema, then okay, copy the data into the new schema. That would be a lot better. That would be a lot better way to handle it. In any case, we are going to take the short way out, and we're just going to worry about the onCreate statement. Okay, here's the warning I already mentioned. OnCreate is only called one time, period. End of story. So it's a good idea. You know, what I wouldn't do is try out a little database schema, throw it in the debugger, shut down the debugger, try to change, throw it in the debugger, shut down the debugger. Because onCreate is only called once, we really want to think about what our database structure is going to look like. And we want to try and put the whole thing in this onCreate statement before we run the debugger. So we want to bring that to completion before we run the debugger. So if you do have to make a change, it gets a little bit tricky. It's doable, but it's a little bit tricky. So in any case, try to think of your entire schema, because that onCreate is only called one time, the very first time you try to access the database. Okay, SQLite Open Helper, the superclass we're going to extend, has methods that will give you access to a readable and writable database. Okay. SQLite database then, which we can get from SQLite Open Helper, has methods to do our normal CRUD operations. So what's CRUD? Create, retrieve, update, delete. That would make for a very good quiz question. Okay, so the SQLite database object that we get from our SQLite Open Helper has methods that will help us do these create, retrieve, update, delete operations. A cursor is basically like a result set. It allows us to access data that gets returned when we do a query that selects data. Okay, so the indices are zero-based, which means that within a cursor you say you use a get. You say get int or get double or get string, and you provided an index. So you say, okay, I got a result set back. I want to get the very first data cell that is, an intersection of a row and a column, and I want to retrieve that data as an int, or I want to retrieve it as a string. Remember that SQLite itself doesn't have data types, but we can use this getInt, getString, so on and so forth, to retrieve the data and tell it that we want it in a certain data type. So we'll definitely use that. Content values is kind of like a hash map, where cursor is getting data from the database, content values is putting data into the database. So in this case, we can take a piece of information like a plant or a specimen, and we can move data from there to content values and then say SQLite update based on this here. Okay? A quick example of fetching just one row and then fetching multiple rows. We'll look at how we can do this, and then creating a content values. Okay, so we'll go back to Eclipse now. We know we need to extend SQLite Open Helper, but that's a lot of typing. So what I'm going to do is use a little shortcut that's fairly universal in Eclipse. If I type a name here, it will pull up classes that match that name. But a shortcut is, if I start typing only capital letters, it will select, of all the classes visible in this project, it will select only classes that contain those capital letters. And you see when I do SQLOH, it narrows it down to SQLite Open Helper. Okay, and there we go. What method stubs would you like to implement? Inherited abstract methods, that's good. Everything looks good, so I'll choose finish. Okay. And here we go. We have a fetch plants by search. We will need to actually have a plant table first, which we don't have yet to activate this one. Right now, my bigger concern is giving the ability to save specimens in an offline mode. So, okay, what doesn't it like here? Okay, it's giving us a constructor error because take a quick look and remember what I said about constructors. We will get a default no argument constructor. Okay, we'll get a default no argument constructor if we don't provide one. But the trick is we have to have some way to invoke the constructor from the superclass. Sorry, 1 second. So every once in a while the screen capture software loses focus and I have to grab it again like that. Okay, you probably don't notice it, but I do. There's a little red border that shows what I'm recording, and sometimes that goes away and I don't know if I'm centered or not, so I have to go get it back. In any case, okay, what it's telling us is we have a default constructor, but in this class, offline plant DAO. But the problem is SQLite Open Helper does not have a default constructor. It has a constructor that has 4 parameters. So what we need to do is figure a way to invoke that constructor from this class. And we can only really invoke a constructor from another constructor. So let's start by writing a constructor. Offline plant DAO, public offline plant DAO, boom. Okay. Oh, what don't you like? Okay, I see. Super. And let's see if it will give me any context-sensitive help. It looks like no. Okay, not a problem. We'll go look this one up. So we're looking for SQLite Open Helper. There we go. And let's see if we can find documentation on the constructor. Okay. We have to give it a context. This is probably one of my least favorite parts about Android, is that the context. Let's look at this guy. Okay, context is an abstract class. An abstract class that basically tells us about our application's environment. One of the things that extends this abstract class is activity. What's an activity? An activity is our screen. It's our UI screen. Well, because the SQLite Open Helper needs to know a little bit about our application, the constructor requires a reference to a context. And again, context is an abstract class. It's extended by our activities. So our activities will fulfill this role. What I don't like is that is mixing the UI layer with the persistence layer, which is a big no-no. Okay, needless to say, we'll find a way to work around that. Okay, string name, that's the name of our database. Cursor factory is a factory that will make our cursor objects. We can just specify null and go with the default. And then version just tells us what version of the database we're using. Version being the version we wish to give our schema. So we'll give that version 1. That'll be fine. Okay, so now what we'll do is we'll call super. Okay, and then we'll say context. We'll fill in that blank in just a moment. That's going to give us a not defined variable. Okay, plant places will be the name of our database, null for the cursor factory, and then version 1. Of all of these things, we're able to hard code everything except for this context. We're going to have to get that reference from our actual activity. So we're going to have that passed into this constructor. So I'm going to say context, context. And again, I don't really like this because as soon as I Control-Shift-O, notice that, well, I guess it's inevitable. This persistence layer is pulling in Android packages, but I am a bit bothered that it appears to have a hard-coded dependency back to the UI layer. There might be ways around that, but I haven't found a good one yet. So there we go. Now we compile. Okay, and next we need to think about how to create our database. To create our database schema, we need to go down to, 1 second. Sorry, one more second. Offline plant DAO, I'm in the wrong class. We need to go down to our onCreate statement. And first of all, that arg-o isn't doing much for me. I'm just going to call that db because that's a reference to our database. Okay, and db. Okay, what we need to do is we need to call db.execSQL. db is a reference to the SQLite database class that we have. And what we can pass into here is, say, a create table statement. So, just normal old SQL. I'm hard coding it in a string, which probably isn't a good idea. It'd probably be better to have this in some external file and bring it in dynamically. But nonetheless, here we go. So, okay, execSQL. First of all, we'll do _ID, and we'll say integer, primary, space key, auto increment. And you might say, wait a minute, integer, I thought you said that the database is not typed. That's true, this is just a suggestion. And by the way, I'm going to go ahead and, to get rid of the red line, double quote and terminate with a semicolon. Okay, next, let's say plant ID, that'll work, int. Okay, next we'll say latitude. I really want to call that text in this database. I don't want to introduce more floating point problems. Oh, you know what? I'm missing my create table. Sorry, I need a create table first. Create table specimens. There we go. Latitude text, longitude. Move this over so we can see it better. Text. Let's see. Description. Text. Published. Int. What published means, and trust me, this was one thing I really liked. When I do travel around the world and get pictures, usually I will save them locally to my phone, and then when I get home, I'll upload them. But I don't want to upload ones that I've already uploaded. So when I upload data from my phone, I will typically keep it in the phone's database, but I will change published from 0 to 1 to basically say, okay, I have successfully moved this data from my phone to plant places. And Then the next time I go through and upload data, in my query, I'll say only upload data where published equals 0. In other words, only upload data that I have not yet published. So that's one that's not visible to the user. It's more of a control field or a tracking field, but it's one that's been very handy to me. So latitude, longitude, description are foreign key to plant. Looks like I'm missing a comma here. And again, this is tricky because we are hard coding a string, and you know what? I see something else I'm missing. Yeah, we have to be very careful. After create table specimens, we need an open paren, and then we need a closed paren within the double quote, and then a semicolon. Like I say, this is pretty nasty because we have we basically have a SQL statement as a hard-coded string. Once again, when I did this exercise, I was using the Apress book, which is a publisher I will swear to never use again. Um, the O'Reilly book, I haven't read their part about SQLite. I would imagine they probably have a better way to do it than this. And not only did Apress really tick me off by having a book that just really I didn't like, but it's the only time. Usually, as a professor, I get books sent to me all the time. Happens all the time. It's the only time a publisher wrote or called the department, called the administrative assistant, and said, "If you don't use our book for your class, you have to send it back or pay us for it." That really just kind of snubbed me. So, in any case, and the book really sucked. But in any case, the O'Reilly book maybe has a better way to do it than this. If so, do that. I'm not really keen on how this is done here. But there we go. So we're defining an auto increment primary key of ID. I'm going to double check, make sure I have all my commas in the right place. Then a plant ID, which is going to be our foreign key. Okay. Then latitude and longitude, which we'll have as text. Description is text. Published as an int because we can't have booleans, but we can have ints. So that's my specimen table. This one's going to get used a lot because this one is where we're going to be writing data as we get data from the GPS. So as we're out in the field, this one's going to get written to quite a bit. This will be one of the more active tables we're going to use. I could also make a plant table, probably not a bad idea. So while I'm here, I'm going to make another table. We'll say, and I just did a copy paste, create table plants, ID, that's fine. Okay, plant ID we don't need. What were our other attributes? What were our other attributes in our DTO for plant? I'll just take a look here and we'll model it just like that. So let's see, plant has genus, species, cultivar, common name, category, minimum height, maximum height. Or you know what? Did I show you the right one? Yes, I did. Okay. Genus, species, cultivar, common name. That's easy. Category, minimum height, maximum height. Okay, no problem. No problem. So we go back and offline plant DAO. Okay. So genus, text, species, text, cultivar, text, common name, text, category, text, minimum height, int, maximum height, int, and what else? Minimum height, maximum height. I think we got it all, actually. I think we have it all. Yeah, okay, that works. Okay, and then terminate with a semicolon and a double quote. Okay, this works for me. This works for me. And we save. Okay. So, this will start us off. The next thing we're going to need to do is we're going to want to save our specimens into this database, which means we're going to need to make a method called something like save specimen or update specimen, and it's going to accept our new specimen DTO. Okay, so it's going to accept that specimen DTO. And this is going to get pushed down, whoops, sorry, I'm trying to pull up the debugger here. This is going to get pushed down when we hit save location. That's going to effectively call our save specimen screen. So we're going to have to go from this activity through the plant service, through our interface, all the way down to this save screen, or save method that we're going to need to make in here. So I want to do that, but I'm hitting the 40-minute mark. And I want to go ahead and save what I've done now, and then we'll start another presentation and we'll actually implement saving this specimen. Thank you.